All right, so we just saw that we can annotate a function parameter type to be some object. We can do the same thing for a return type, and we can do the same thing for a variable if we wanted to. Now, it's kind of odd to do this, but I just want to show that it's possible. Let's say I have a coordinate variable, and I expect it to follow this pattern. X is a number, and Y is a number. Okay, if that is the shape I want for coordinate, I can specify that manually, just like I would specify, string or number. But instead of specifying a single type like that, I add in my object type like this. So coordinate is of this type, and then I set it equal to the actual object. This is what's kind of confusing to people. This is the type. Now these curly braces are the actual object, and I would say X is 34, and now it's going to complain and say, whoa, you are missing Y. So I'll add in Y. Y is 2. And there we go. I've got my object, an object literal that I set up a type for on the same line, which is a little bit odd to do that. But it is totally valid to type your variables this way. So you say this is the pattern it should follow, and then you make it follow that pattern. So I can also annotate the return type of a function. Let's say I write a function called make random coordinate. And it's going to return an object that has an X as a number and a Y as a number. So I could add that annotation right here. It should return X as a number, Y as a number. Now this is kind of confusing. It's extra confusing, right? Because curly braces in JavaScript mean more than one thing. Here, these curly braces denote the function body. Here, these curly braces are, this is TypeScript, but they denote the object type that is returned by this function. So just like if I had said void, that's the type, it's supposed to return void. This is the type. It's supposed to return an object that follows this pattern. So if I return an empty object, it's going to complain. You're missing X as a number and Y as a number. So let's do our math.random maybe. So it returns a random X, they're very small coordinates, and Y is a random number as well. And there we go. So not useful really in this situation, but I wanted to show this is valid as well. We can have a function with a return type annotation of an object literal. We can have a variable where we use a object type. And of course, we can write the parameter type annotations for a function to be an object as well.